Okay, so hi guys. In this video, what I want to do is I want to go over an example. So this is a video over integration by parts. So I haven't, at least I don't think I've done as many problems over this as I thought I had on YouTube. So I'm going to go ahead and go over this problem, and I will make a whole playlist regarding problems with integration by parts. So this is for those of you that are in Cal 2. So it says integrate the following using integration by parts. Now, with all of these, there's always a specific formula that we use before anything. So the integration by parts formula is the following. The integral of, let me do u dv is going to be equal to u, so it's u, and then times v. So let's make v a different color. So let's make v green like that, and then minus the integral of v du. So it's gonna be v and then du. Okay. So I just want to make that clear before anything, because we're going to have to use this for any of these integration by part, these problems. So there's another thing I wanted to mention, and it is an acronym. It's called LI8. So that's yet another thing that I want to make very clear. And this is what's going to define u. So I just want to make that clear before anything. So this is how we know, what to make u, our variable u, be. So it stands for, and I'm going to just quickly go over this, logarithm or logarithmic, inverse, algebraic, trigonometric, and then exponential. Okay, so this will determine what we will have in terms of the our integral, like what, depending on the integral that we have to integrate, this will determine what u will be. Now, looking at the problem, let me just go ahead and rewrite it. We have the problem, the integral of x cosine of pi x dx. So notice that there is, according to this, right, there are two things going on here. There's a algebraic expression, so this is algebraic. And then there is a trigonometric expression, so the cosine of pi x is trigonometric, okay? So this would be my trigonometric expression. So just to kind of make it very clear, this is this one, and this is this one. So according to my rule, according to my acronym here, the algebraic comes before the trigonometric. That's because if I'm looking at this clearly, there's an algebraic and a trigonometric, and according to this rule, the first one that I come across is algebraic. So this means that I'm going to make u equal to x. So that means that so this is going to be u, basically. And therefore, the other part will be dv. So this entire part, cosine of pi x dx, will be my dv. So that's how we know what u and dv are. So now we've got that out of the way. And again, the integral, and let me just rewrite this again. So 1 second. Okay, so again, this is my formula for integration by parts. And now let's go ahead and label my u and v. So like I said, u is x, so let's go ahead and list out everything. So u is equal to x, and then dv was cosine of pi x dx. So let me just kind of, so dv is cosine of pi x dx, okay? And now, so I got those two out of the way. So far I have the integral of, it's going to be x cosine of pi x dx, and this is going to equal, and I have uv, so I'm going to do u first, so I have x, but I need to find v, okay? And also, I need to find du. So I have u right here. U is x. I need to find du. So du is really just the derivative of u. So du will just be dx. And now dv is this one. So now I need to find v. In order to find v, I need to integrate this stuff here. So if I do that separately, v is really the integral of cosine of pi x dx. If you guys don't know how to do u substitution, I'm going to go ahead and explain it here, but you really have to know u substitution well. And sometimes I will admit that I do have to work it out. So here, I'm going to integrate this by u substitution. I'm going to make u equal to pi x, okay? And then du is just going to be, it's going to be pi dx. So then, if I solve for dx here, I'm going to divide both sides by pi. So then I'll have dx is equal to du over pi. Now, this will be, so v is going to be the integral of cosine of u, right? So really, we're just trying to find u here because we need it in order to do our integration by parts method. And then dx is really what goes for this here. So really, it's going to be du over pi because that's what dx is. Now we have the integral of cosine of u du over pi. We can take that 1 over pi out, okay? Because since there's a denominator of pi, we can literally just say v is equal to 1 over pi integral of cosine of u du. And now we know that the integral of cosine of u is going to be sine of u, okay? So, so then this will be 1 over pi, and again, the integral of cosine of u du from our common table of trigonometric integrals is sine of u. So it's going to be 1 over pi times sine of u, and then plus our constant of integration c. But again, we don't need that because we're trying to find v at the end of the day. And then if we substitute u back in, it'll be pi x. So really v is going to be 1 over pi, or it's going to be, I'm sorry, sine of pi x over pi. Okay. So now we found v. So now we got that out of the way. So I know that v is now sine of pi x over pi. So let's go ahead and write that down here. So that's kind of what makes these lengthy, guys, is that sometimes we have to do a little more work involving other trigonometric, other integration methods, such as u substitution. So then we're going to have, so then this, let me just kind of, hold on guys, 1 second. Okay, so now let's go ahead and continue this problem. So it's going to be x, and I'm going to put in my v part. So v was sine of pi x over pi, so let's go ahead and put that in. So it's going to be x times sine of pi x over pi. So you have to really pay attention to how I'm aligning it here. It's because this is very important. This is u, and then this part was v. Okay, and now we're going to do minus the integral, and it's going to be of v, so v again was sine of pi x over pi, so it's going to be integral of sine of pi x over pi, and then du. So du, I'm sorry guys, du is dx, so basically it's going to be dx here. So as y'all can see, I'm literally just aligning everything right now. And yes, these problems are really lengthy. And the reason why I'm explaining it step by step is because these problems are really hard. So then let's go ahead and just clean things up a little bit here. So we can bring these two together, right? And again, I'm just gonna kind of get in here, x cosine of pi x dx, I'm just kind of taking off the colors here, is equal to x sine of pi x over pi minus, and it's going to be, I'm going to take out the 1 over pi here, because really, this expression is 1 times sine of pi x over pi. If I can literally say this as 1 over pi times sine of pi x. So I'm going to write it that way. Okay, I'm going to take out that constant. So 1 over pi integral of sine of pi x dx. Okay, we're almost done. Okay, so then now we need to we're still not done here. I mean, we're almost done, but not quite yet. We need to find the integral now of sine of pi x. So now we need to integrate this, okay? And so again, I'm going to do that separately. So this part here, I'm just going to say it right now. I'm going to do it separately. So this is going to come over here. So I'm going to do sine of pi x now. And again, that's going to go for here. I just want to make that really clear right now. That's what we're going to put in for there. So we're going to do that separately. So then if I use u substitution here, I can do this by u substitution. U is equal to pi x. So I'm going to do, and then du is going to be pi dx. So I'm going to do du. And just solve for dx. We always want to solve for dx with these. So then this is going to become sine of u, because u is pi x, right? Okay, and again dx is really du over pi. So it's going to be sine of u, and then times du over pi. And again, we're going to do that same thing we did, where it's really the integral of sine of u times 1 over pi times du. So we can take this out because it's a constant. We can take that out. So we're going to go ahead and take that out. So it's going to be 1 over pi integral of sine of u du. Okay, and now we're going to do the integral of sine of u. The integral of sine of u is really negative cosine of u. So this here, I'm just going to state it right now, it's negative cosine of u. So it's going to be 1 over pi times negative cosine of u. All right. Now here, this entire thing is actually going to be, so we're going to bring the negative and 1 over pi together. So it's going to be negative 1 over pi cosine of u. If we substitute u back in, it's going to be negative cosine of pi x over pi, because again, u was pi x, okay? So here, for the blue part, we know that in all, we're going to have the integral of x cosine of pi x dx is equal to x sine of pi x over pi minus 1 over pi times, and it's going to be what we just said, which was, I think it was negative cosine of pi x over pi, if I'm not mistaken. Give me a second, guys. Okay, guys, so like I said, yeah, this is what this becomes here, the blue part. And now let's just bring it all together. So, if we just kind of do some algebra here, this is going to be x sine of pi x over pi. If we distribute this in, it's going to be plus. It's going to be cosine of pi x over pi squared. Yes. Plus our constant of integration c. We can end it here. You can, if you want, you don't have to, but you can go ahead and, what is it called? Factor out the 1 over pi. So, I mean, you don't have to, but another way of saying this is like 1 over pi times x sine of pi x, and then plus cosine of pi x over pi plus c. But again, this answer is good enough. If they have an answer like this is also a good answer, but I would go with this one. But that is how we would integrate this problem using integration by parts. So just know that with these problems, guys, it is really, really lengthy. So I do apologize if this video is a bit lengthy, but I really want to make sure that we understand the process. So that is going to be it for this video, guys. If anybody has any questions, please let me know. And also please like, comment, and or subscribe. And I will see you guys in the next video. Bye, guys.